sample proportions, finding a particular sample size for a particular standard deviation. Remember that the equation for the standard deviation of a sampling distribution when it involves proportions is equal to p times 1 minus p over n, and I take the square root of that. Okay. The sample size controls how large this standard deviation gets. The bigger the sample size, the smaller the standard deviation. And we know that the bigger the sample we take, the more accurate our results are anyway, so the two go hand in hand. But there'll be times where I want a particular standard deviation for my sampling distribution, and I would control that by my selection of the sample size. So suppose we take a sample of size 616 from a population with p equal to 0.56. Okay, we know that this is the standard deviation of the sampling distribution, that formula. So I can solve that quite easily by taking the square root of 0.56, and then 1 minus p would be 0.44 divided by 616, and then I'm going to take the square root of that. And that ends up to be about 2%. Okay, so that means that taking samples of 616 from this population is going to yield a sampling distribution with a standard deviation of about 2%. Okay. Now, suppose you want to lower that standard deviation to 1%. Okay. What sample size would be needed? So 2% apparently was too big. Okay. And I really want it to be 1%. So the only thing I can control is the sample size n. Okay. So what I'm going to do is replace that 1% for the 2% up here, and then I'm going to solve for a new sample size. Okay. So I'm going to start with my formula. So p times 1 minus p over n. I know I want my standard deviation sampling distribution to be 1%. And I know my p is 56% and my 1 minus p is 44. What I don't know is what sample size will get me that 1% standard deviation. So now I just solve this. So the first thing I would do is I would square both sides to get rid of the square root. And that gets me 0.0001 equals 56 times 44 over n. Then I could multiply both sides by n to get it in the numerator. And then I'm going to divide both sides by 0.001 to get rid of it over here. So my final answer will be n is equal to 2464. Okay. Now, if you look carefully, my original sample size was 616, okay? And if you take 2464 divided by 616, you'll notice that that is 4. So my sample size increased 4 times, I got by 4 times as big, okay? So my original sample was 616. When I multiply that by 4, I actually get the sample size for 1%. So I wanted to cut my standard deviation in half, but I had to multiply my sample size by 4, okay? And the reason for that is, remember that the sample size, if you look in the upper right-hand corner, that sample size is under the square root symbol, okay? So if I multiply the sample size by 4, when I take the square root of that, it really becomes a 2, and that's in the denominator, so it's really cutting the standard deviation in half, okay? You can imagine if I wanted to cut the standard deviation by 1/3, I would have to multiply the sample size by 9, okay? So you really have to increase the sample size a lot to get these changes, okay? Like to cut it in half or to cut it in 1/3, I have to make a dramatic change to the sample size. But all we have to do is solve that equation for n.